Guys, welcome back to day 16. Sometimes life gets in the way. You're focused on one task and another thing surges and you have to focus all your energy and your attention towards that. That doesn't mean it's the end of whatever you're pursuing. It just means you have to be able to apply a little bit of BFS. Instead of going deep in one thing, maybe you have to open your scope a little more and figure things out from there. That's what happened to me at the end of last year when I was really focused on solving a lot of leak code problems. I finally got approved for my green card and I took a trip back to my hometown to celebrate. So I'm going back to all these videos, editing, putting it together and uploading to YouTube. So I hope you follow along. Today we're solving leak code. I think it's inserting intervals. So let's do it. I hope you enjoy. Let's jump right into it. Alright, welcome back everyone. Today we're going to be solving insert interval problem. We are basing our problem list on Grind 75, basically the new tool. The same author of Grind 75. He created this website and it's pretty cool. Basically, you know, neat code and all those websites have certain similarities in that sense, but I like the way this is organized. I like that I can order by topics. You know, everyone chooses whatever platform they think it's the best, but at the end of the day we're solving the same problem. So basically it's just different orders based on the intuition of that particular creator. At the end of the day we're solving the same problem and we have to find the best way to learn. In my case, I wanted to show you that I've put together this reference sheet where I add problems and algorithm tricks and key insights to help me basically memorize and create intuition at the same time. Memorize because I use the name of the problem and the key insight on a flashcard on Anki, right? So I create the problem in the front and then I ask the key insight about it. That way I can start associating things together. But obviously I practice the code in different ways. Like I try to implement each algorithm at least 3 times. One from the reference once I have it. The second time I do it from memory. And the third time I do the flashcard and I go through the problem again. So I'm just trying to build intuition in that sense. But yeah, some websites recommend you to do merge interval before, so this problem before you do this, because this problem basically built on top of that one in some sense. Different ways to solve it, I'm sure. I attempted this one, I didn't get it. I was doing something quick and I really didn't get it. I was trying to get out of order and do like, you know, do this first and then that one, but I was like, you know what, I'm just gonna stick with my plan, which is doing this first and then number 7 here is merge interval. So I'll go back to it and do it in another video, but today we're gonna be solving insert interval. And basically we get a intervals array. It's an array of array where each element inside the array has 2 elements that represent starting point and an end point, right? So start and end, and basically this whole array is going to be sorted in order by the starting point, meaning the first element of each element inside the array is going to be sorted in ascending order, right? So from 1 all the way up to 12 in this case, and we also get a new interval as part of the problems in this is our task. We have to insert this new interval inside the intervals array and keep the sorted order. But it's interesting because we have to find if there are any overlapping intervals, and if there is overlapping intervals, we have to merge. So that is basically our task. Just so you see like the how useful this reference sheet is to me. Basically I look at the problem here, and I see, for instance, insert interval, I see that says merge while scanning, right? So now I know I can solve that in linear time, one, and also I can handle the new interval placement and merging at the same time. So that's the key insight, and that's the algorithm trick. That's how I use this reference sheet. I basically put this together by solving other problems, by Googling a lot. There's a lot of resources out there, but I've been collecting these problems, and I try to practice them on a three-way, which is like I come here, find the problem, see the reference, implement it, then I do it from memory, and then I do it from a flashcard. So I try to memorize and build intuition at the same time, basically like a BFS, DFS approach, right? I don't try to go too deep in one thing without exploring a bigger scope. So I basically check the breadth. At the same time, I go down and check the node, right? So that's just the way I like to build the intuition. So how are we going to solve this problem? Let's pull up our whiteboard, and basically, let's see if I can copy one of these right here, just to bring it up here. Perfect. And then we also have the new interval that is going to be equal to this. And perfect. Okay, let me add these. We'll see, they won't let me. All right, perfect. So this is what we have, right? Let's imagine that we have, let's put this on a line like this. And these are our intervals from 1 all the way to 16, right? And these are, let's imagine these are a point on a line, right? These are all points on a line. And we have our new interval. Let's put our new interval in red that we have to insert. Based on this given input array, our new interval will fit somewhere around here, right? Because we have, we have certain order, and I'm gonna do it by starting point. Let's say, start right there, this one start right there, this one start right there, there, and there. Okay, so let's just say that's our line, and our new interval would be right about here, right? After 3, before 5, that's our new interval. So if we have 1 and 2 here, and then we have 3 and 5 here, and then we have 6 and 7, and 8 and 10, and 12 to 16. We'll just keep it like that. But our new interval right here, starting at 4, so let's say, right about here, all the way down to 8. What do we see here? Well, we see that this interval is overlapping with everything that's underneath, right? So all that, it's overlapping intervals, because this interval right here started before but ended after we started. So that's overlapping right there. Same case for 6 and 7. They started before and after we ended, right? So it's basically it's an interval that's getting shadowed by our new interval. And this interval right here, where the 2 points are colliding, basically. My ending point is colliding with the starting point. So we know that. So what do we see here in this example? Well, first, let's check here that we can create a new output array. We don't have to solve this in place. We can create a new output array. So we're gonna call it result, just put it there. The first thing we see here is that there are intervals that started before our interval ended. or interval started, and there are intervals that start after our interval ended. So we have intervals that ended right here before we started, and intervals that started after we ended. Make sense? So those are two scenarios. Another scenario could be if our interval would be 0, 0, right? In this case, our interval starts and ends before we even have to get into the input array, right? So I'm gonna keep that down there just to keep it as an edge case. So how do we build this algorithm? Well, first, let's say our first case would be check if our new interval ending point, right? We want to see when it ends. If our ending point is greater, if our ending point is less than the starting point of the first interval, and we're going to basically find this iterating, and I think we already know that, right? This line represents an iteration from here all the way to there, right? So we're going to check every point. We're going to check every point. Let me do it like this, of this line. So the first thing we're going to check is if our ending point right here is smaller than the starting point. Because if that's the case, we don't even have to touch this. All we do is add our new interval directly to the results and return the results plus the interval, the input interval, okay? But in this case, we have right here in this particular example, 8 is greater than the starting point right here, right? So we know that immediately it's not the case, right? So what is the next thing we have to check? Well, if this interval started after this interval ended, we know we are inside the range, inside this set of intervals. Okay, so this is the case. 4 is greater than 1. So now we know that 8 is so 4 is greater than 2. So we know this interval starts before our interval, right? So what do? Well, if our interval here was smaller, we would add the interval directly into the new interval directly into the result list. But since this interval it's smaller in our example, then we go ahead and add this interval down to our result list, right? What do we have left? Well, we have the next iteration. The next iteration asks the same question. Is this interval less than the starting? No. Is this starting point right here greater than this? No. So what happened? Okay, well, now we have a collision because our points, and I'm gonna move these back here where it was, right here. Well, I know that my starting point, it's not greater than my ending point right here. Meaning this ending point ends after I started. So that is what we call a collision. This point, ending point, is greater, meaning it ends, we can see right here, it ends after we started. So we are overlapping right here. So what do? Well, remember I said this was dynamic here, right? What do I mean by dynamic? Well, we have two values. So we can say the way we solve this is like, and I'm going to eliminate this example now because that's not the case. So we have an overlapping interval. How do we modify this? Well, we're looking for the main starting point and the main ending point so we can merge because we have a collision right there, okay? So what do we say? Well, I want this value right here to be the minimum value between these two. because I want to grab the main starting point. I don't wanna grab this value here, because then I would overlap. I would still overlap. So which value do I want? I want the minimum, which is 3 in this case. And then I want the maximum value between these two, because I want to end in the last possible interval. So I want to start in the first possible interval, and I want to end in the last possible interval. So between 5 and 8, obviously 8, and that is our second iteration right there. Okay, so this is the point we are right now. I'm gonna go ahead and delete this, and our new interval is 3 and 8. So we can delete this, right? So I'll move these up right here, and now we are let me get, okay, right over here. So we went through here, right? And we said that there was a collision, or an overlapping, I should say. No, not collision, that's a totally different thing. An overlapping interval. So I grabbed the principal starting point, or the last possible starting point, and the greatest ending point, which is the 8 I already have from my 4-8. So when I check here, again, I'm gonna ask the two same conditions. It's the ending point of my interval less than this? Nope. Meaning my interval doesn't start before. So then what happens? Well, is this greater than this? Nope. Meaning this interval doesn't go before, so there is another collision. And I do the same process again. I want to grab the minimum value from here and the maximum value from here. In this particular example, stays the same because the values are inside our interval, so there's no really a minimum or a maximum value. So we move, this stays the same, we move into the next iteration. Here's something interesting happen. Well, this value right here is not greater, this value right here is not greater than this value right here, and also this value right here is not less than this value right here. Interval 1 is not less than this value right here. So we have a collision, and what do? Well, same thing. Let me move this guy over here. I want to grab the minimum value, stays 3, but here I want to grab the maximum value, and 8 gets updated to 10. Perfect. So now I have the maximum and the minimum value right here. What happened next? Well, it's interesting because now we're outside of the overlapping zone. So what do we do next? Well, we ask the same question. We still have our 3 and our 10 here, and we ask, is this interval less than this interval? Yes. So what does that mean? Well, it means our interval, or whole interval, goes before this interval, because it ends before this starts. So what do? Well, we send this 3 and 10 interval to our resulting array, because we know we're done with it now. We found a value or an interval that starts after we finish. And then all we have left is what? Since we don't have any overlapping interval, well, all we have left is adding this interval right here, and that is our resulting array. 1, 2, 3, 10, 12, 16. That's basically it. And as we can see right here, 1, 2, 3, 10, 12, 16. So that is how we're going to approach this problem. Basically, we have 3 conditions to check. We're going to check if there are intervals that started before. We're going to check if there are intervals that started after. And we're going to merge everything that overlaps, okay? We're going to do that by sending the intervals that are ending before our new interval, and the intervals that start after we finish. And then we are going to treat our new overlap or new interval dynamically. So how do we build that in code? Again, there are multiple ways to do that, like for all problems basically. Let me make this a little smaller so I have that on one line. The first thing I'm going to create is my resulting empty array, and as it says here, we can do that, and it doesn't have to. We don't have to do that in place. Okay, so we're gonna iterate for every item in range line of intervals. The first thing we're gonna check is if our new interval at our ending point is smaller than intervals at that particular index at the starting point. If that's the case, then we can oops, big mistake here. I forgot to add the if statement. Okay, so if the new interval at our ending point, basically if this new interval here is less than this interval right here, which is not this particular case, but if our interval ends before we even have to check the rest of the intervals, then what we're going to do is append our new interval, right? And we can go ahead and return that new list plus intervals from I all the way to the end. Here we go. That's how that goes. So basically, if our interval starts before we have to get into the intervals, well, go ahead and append it, return it, and append the rest of the intervals from that point to the end. Simple. The next condition is if our starting interval, so our new interval at starting point, is greater than intervals at that particular index at the ending point, right? Meaning our starting point right here, this number is greater than this number, which is not the particular case for this example either, but if that's the case, that means the interval, this interval right here goes before our interval, right? So let's see if I see an example here. New interval at 0 is greater than that. So perfect. Okay, for here we go. So this interval right here, for the example we had, basically. Let's modify here, but 4 is greater, we see here new interval at 0, 4 is greater than the end of the interval, meaning this interval ended before we started. And if that's the case, all we have to do is append that interval to the list. As simple as that. And the last case we have is if we have a collision. And we say we want to treat the new interval array as dynamic. So we are going to reassign new interval. And what do we want? We said we want it, remember, the minimum value between. So I want reassigning new interval inside a list, basically playing with both values, and I want the minimum value, or the first value, to be equal to intervals at that particular index at the starting point. So I want the minimum value between the two starting points. New interval at 0. So the minimum value between those two basically the minimum value between, I have 4 and 8 here, so the minimum value between these two and the maximum value between these two. And same thing when I get here, the minimum between these two, and so forth, right? Perfect. So max is gonna be between, let me just copy this honestly and change the index 1 and new interval at 1. Okay. Oopsie. Okay. Perfect. So once that's done, I'm checking all 3 conditions. If my intervals start before, if the interval in question start after, and if there's a overlapping interval, and there's an overlap interval. Then after that, I want to, once I'm done, I can merge my new interval. I can merge my new interval because I went through all the conditions, I modified and got the minimum and the maximum value for every item. Then I can append that to my resulting array, and then I can just return the resulting array, and that should be it. Nice. Perfect. Okay, let's submit it to make sure that's the case. Boom. Beautiful. See that confetti coming up. Awesome. Okay, that was great. Actually, 1 millisecond, not too shabby. We know, oh, okay, I guess I've used all of them, but we know this is, you know, we are only iterating over the array of interval once, and as I show you here, I am merge intervals. Nope, insert intervals, insert. Perfect. I'm merging while I'm scanning, and I'm handling the new interval placement and merging at the same time right here. And that's it. That's it for this problem. I hope you understood. Let me know if you want these reference sheet. I'll send it to you. I have 81 problems so far, but I'll keep updating it. So just let me know, and I hope you enjoyed this video. Like and subscribe. Follow my journey, support my journey. Let's do it. Thank you.